UN 영어뉴스 How Canada's wildfires are warming the stratosphere. Extreme wildfires are increasing due to rising emissions, but they also disrupt the climate in return. Weighing up the overall impact, however, is trickier than it seems. Apocalyptic images of wildfire devastation, from charred homes to cities shrouded in deadly smoke, are fast coming to embody the world's unfolding climate disaster. In Hawaii this August, the death toll is still rising after the deadliest U.S. wildfire in over a century ripped through Maui. In Canada, extreme fires blazing across the country are more widespread than at any other time on record. Research has shown that wildfires' likelihood and intensity have already increased due to human-caused global temperature rise. But there is still so much we don't yet understand about these powerful phenomena, not least wildfires' own ability to alter and disrupt climate systems long after their flames die out. One of the most far-reaching ways fires impact the climate is their ability to release vast quantities of carbon stored in trees and soils into the atmosphere. In a vicious feedback loop, the additional CO2 then contributes to the same long-term warming of the planet that makes the fires themselves more likely. In 2020 alone, California's wildfires were estimated to have negated 16 years of the state's cuts to greenhouse gas emissions. Forest regrowth may occur, the researchers suggest, but not fast enough to help keep global warming under the 1.5°C limit. Not all of wildfires' impacts on climate are so long-lasting, however, nor do all produce warming. By blocking sunlight and attracting additional water droplets that brighten clouds, smoke aerosols can reflect sunlight back into space, leading to localized cooling in the lower atmosphere. This cooling effect typically only lasts until rain washes the aerosols back to Earth. Yet, as wildfires increase in scale, even these more temporary impacts are expanding their reach and duration. Australia's 2019 to 2020 fire season, for instance, produced a widespread smoke-induced cooling that may have influenced the recent triple dip in the La Nina weather pattern. Research suggests understanding how wildfires' various impacts interact is therefore key to understanding their overall impact on the climate, and thus to guiding humanity's attempts to limit dangerous climate change. Super outbreaks. Calculating the net warming or cooling effect of wildfires means considering their impact across various timescales and levels of the atmosphere from surface up. One avenue of research has thus focused on the stratospheric reactions that take place 4 to 31 miles up in the air. Beneath this level, the lower troposphere is warming due to rising levels of CO2. Yet, the same trend is also cooling the stratosphere, where thinner air allows the carbon dioxide to release its energy into space. In Canada, extreme fires blazing across the country are more widespread than at any other time on record. Until recently, it was thought only volcanoes or nuclear explosions were powerful enough to interrupt this cooling process by propelling smoke up into the stratosphere. But when large wildfires meet with the right meteorological conditions, they can produce vast, dirty thunderstorms which darken the sky, create erratic winds and tornadoes, and inject large plumes of wildfire smoke 5 to 9 miles above the surface, known as pyrocumulonimbus clouds or pyroCVs. These thunder clouds release aerosols that can travel thousands of miles across the globe. Once airborne, the black carbon in these wildfire aerosols absorb heat, causing them to rise and warm the surrounding stratosphere, says Matthias Stoker from the Wegener Center for Climate and Global Change at the University of Graz, Austria. His research on large wildfires' stratospheric impact has shown that smoke from the pyroCV super outbreak in Australia in 2019 to 2020 caused the stratosphere to warm very strongly by up to 10 C during the plume's early development. Over the next few months, it remained an average of 3.5 C warmer before the aerosols sank back to Earth. Canada has this year seen by far its most active pyroCV year over the last decade, says David A. Peterson, a meteorologist with the U.S. Naval Research Laboratory in Washington, D.C., which is attempting to create a prediction system for the movement of pyroCV smoke and has been building a global data set since 2013. At least 133 pyroCVs have been observed in Canada since early May, with 153 observed worldwide. He adds, more than doubling the country's previous seasonal maximum. However, none of the many pyroCV events observed in 2023 rival the stratospheric impact of the 2019 to 20 Australia super outbreak or the 2017 Pacific Northwest event in Canada, says Peterson. Both produced stratospheric smoke plumes that rival or exceed the impact from the majority of volcanic eruptions over the past decade, he says, persisting at high altitudes for many months. Stratosphere versus troposphere models clearly show that the conditions for pyroCV wildfires are set to increase, meaning there is the potential for the effects of such aerosols to become significant enough to change dynamics in the stratosphere and have consequences. Stoker says one particular concern is that the recovery of the ozone layer, which blocks harmful ultraviolet radiation, could be delayed, and research has already demonstrated some negative impacts. Charred surfaces after wildfires can reduce the albedo of landscapes, leading to an increase in warming on the surface. Exactly how stratospheric warming could affect weather, almost all of which occurs in the troposphere, is not yet known. However, changes in the heat of the stratosphere in turn changes the circulation of winds, says Karen Rosenloff of the National Oceanic and Atmospheric Administration, NOAA's Chemical Sciences Laboratory. Changing the winds can change how waves propagate in the stratosphere, and that provides the feedbacks on the troposphere. But the impact on surface weather is going to depend on the distribution of the heating in the stratosphere, so it's not really possible to generalize, she says. The big thing we've already learned is that wildfires can be important for several effects in the stratosphere, says Stoker. It's a big experiment, and in my opinion, I don't want to try out the changes. Researchers see there can already be harmful effects. Albedo and evaporation. Wildfires can also influence climate back on the ground. One mechanism involves changes to a landscape's albedo, or ability to reflect light. In the aftermath of a fire, charred surfaces can reduce albedo, leading to an increase in surface warming. Conversely, a reduced forest canopy can raise albedo by exposing more reflective entities such as grass or snow, leading to a cooling effect. Another process involves the evaporation of water. Thriving plants release water from their leaves in a process known transpiration, and water also evaporates directly from the soil and canopies. The surrounding air is cooled as a result, but when wildfires suppress this, warming increases. A 2019 study which investigated the interplay of these factors found that the average surface temperature can warm for at least 5 years after flames are extinguished. Reduced transpiration was found to be the main cause of this, says Jihua Liu, an ecology researcher at the University of Montana and lead author of the study. If there are more frequent and severe fires in the future, this land surface warming may contribute to climate warming, he adds. However, the interactions among climate warming, vegetation dynamics, and fire are very complex and yet to be fully understood. It's a big experiment. While with wildfires impacting the climate system in so many ways, understanding the different interactions and timescales is essential for understanding their overall impact on the long term. We need to understand the net outcomes because we need to understand how fast to reduce our human CO2 emissions, says Stoker. There are suggestions that solar geoengineering, which would simulate the cooling effects of a volcano and wildfire smoke, could help address some of climate change's worst effects by artificially injecting aerosols into the stratosphere. But doing so, when we cannot yet fully model wildfire's myriad impacts, would be unwise, Stoker says. At the moment, we don't know what geoengineering would do. Studying wildfires helps us to understand what changes there could be, but hopefully we won't try a big geoengineering scenario.